We're doing lesson 2.8, graphing linear and absolute value inequalities. This is the last section of chapter 2, so we're going to be testing here pretty soon. Go ahead and update your table of contents and give your page a heading. Alright, the only notes that you really need to take today are the steps to graphing an inequality. Graphing an inequality, all you need to do is graph the regular equation, then decide if it should be a solid or a dashed line, and then decide if you need to shade above the equation or below the equation. Go ahead and hit pause. Okay, let's take a look at an example here then. So we have this equation. There's no squared, there's no absolute value bar, so this is going to be a linear equation, but we need to have it in our slope-intercept form to be able to do anything with this. So we're going to begin by adding x to both sides. Actually, I misspoke there. We need to be subtracting x off of both sides. So then now we can rewrite this equation. Okay, so there's the equation rewritten, and now when you subtract x, the rule we need to remember with these inequalities is that sometimes you need to reverse it, but by subtracting x we don't need to reverse it. We only need to reverse it when you multiply or divide by a -2. But if we look at our next step, we're trying to get y by itself. We need to undo this 2 right here by dividing everything by -2. So this step we will need to reverse this inequality. So we're going to go ahead and divide everything by -2. Okay, there's our step of dividing everything by -2. And now we are ready to rewrite this equation. And again, remember to reverse that symbol. And so that is our final equation that we are ready to graph. Notice that positive and negative made it negative. Then 2 negatives there made it positive. At this point, we are ready to graph our equations. We need to locate our y-intercept. And -2 here. Ooh, that was too big. Sorry. -2, that is our y-intercept. So I need to go on my y-axis to -2 and make a dot. And then I need to locate my slope. Oh, not very good with drawing these circles yet, I guess. So this 1/2 is my slope. That means we need to go up 1 over 2, and it's positive, so we go up and to the right. So for right now, we're just going to put in a bunch of dots. We need to go back and decide if this should be a dashed line or if this should be a solid line. Okay, and because there is no line underneath the inequality, this is just a greater than symbol, not a greater than or equal to. This is going to be a dashed line. Okay, so we have graphed the equation. We decided that it's going to be a dashed line. And now we have to decide, do we shade above or below it? We look at our symbol here, and it is a greater than symbol. So we need to shade the y-axis that is greater than the line, that is above the line. So we're going to shade this entire section up here. Alright, and there is our shaded graph. So what this means is that any point that we pick up in this shaded section will make this inequality, either the beginning one or our final one, a true statement. Anything on the dotted line will not be a true statement. That's why it's the dashed line. If it was a solid line, then yes, it would make it a true statement. But since it is a dashed line, it will not make it true. And anything in this unshaded region will not make it a true statement as well. Alright, let's look at our next example. So this one, we have SAT scores that need to be 900 or less as a combined score. So the X is the verbal score and Y is the math score. Okay, so these are just horizontal and vertical lines that we're going to be drawing in here. So we need to have an X and Y axis. Okay, and then we need to label our verbal and our math scores on our axes. Alright, and then we have to think about how does this verbal score and math score work together. So it's a combined score, and they have to be 900 or less. So that means if we take x and y and add them together, it has to be less than or equal to 900. So let's write that out in an equation. Oops, I made a mistake there. I put an equal sign. We got to change that. It's got to be less than or equal to. Okay, so that's going to be our equation. And again, we need to get into y equals format, so we're going to subtract x from both sides. And then subtracting x does not reverse the inequality, so then we can just write y is less than or equal to 900 minus x. Okay, so we've got our equation. Now we need to graph it. And so we have to figure out some sort of scale. I think we're probably best off to go by 100s on our x and y axis. So go ahead and label your scales 100, 200, 300 on both your math and your verbal scales. Alright, now that we have our scales labeled, we'll need to start at our y-intercept. 900 is our y-intercept, that's our number without x. And we're going to need to go down 1 over 1, down 1 over 1. But because we're working by 100s, it also means we're going down 100 over 100. So there's our graph. And now we should decide, should this be dashed or solid? Because it's got that line under it, we do need to have this as a solid. And then we have to decide, are we going to be shading above or below this? Well, it's a less than symbol, so you need to shade beneath the line, underneath this line here. Alright, so there is a shaded region. Now you'll notice that I did not shade in the negatives because this is a real life situation, that it doesn't really make sense that you're not going to get a negative verbal score and you're not going to get a negative math score. So only 0 and above is a realistic answer. So this green shaded area are all of the possible answers. Okay, so we're going to need this graph for the next question. So let's go to the next page, read the question, and then we'll come back to this. So does a student with a verbal score of 480 and a math score of 410 fit the tutoring company's guidelines? So 480 for verbal, 410 for math. So we go back to our graph, and let's find that point. 480 for verbal and 410 is about right in there. So is that fitting? Yeah, it appears to be fitting, and we need their combined score to be less than 900. So if you add 410 and 480, it does add up to be 890, so that is less than 900. So it is in this shaded region, and therefore it works. Okay, last example for the day. Graphing an absolute value inequality. Okay, the last lesson, 2.7, we learned that an absolute value function is a V-shaped graph. Starts at 0, 0, goes up 1 over 1, up 1 over 1. And then this minus 2 is going to take that parent function and shift it down 2. So let's first start by imagining what the parent function looks like. So recall that the parent function looks like this. And now again, this negative 2 is going to take the graph and move it down 2. So this is a graph that you need to draw. And now we need to decide, should you be drawing this with a solid line or a dotted line? Because it's greater than or equal to, we do need to draw this with a solid line. And I'm going to extend these lines so that they go beyond, or all the way to the edge of our graph paper. Okay, then we have our equation graphed, and now we need to shade it. So we look at this, and it's a greater than symbol. Greater than shades above the line. So we're going to take this whole section up here and shade it. Oh, I realized when I made that bigger, I actually changed the slope of it. That's what it's supposed to look like. Okay, so I need to go ahead and shade in this whole top area. Okay, and there is our final graph for it. And just remember what this shaded region means. At any point in this shaded area will make this a true statement. Anything on this solid line will make it a true statement. If I pick any of these points down here, this is going to be a false statement. It's not going to work. So that's what the graphing of inequalities are. Okay, that was our last example for the day. So you can go ahead and write your summary and your questions. And this is actually our last lesson for the entire chapter. So we will be taking Chapter 2 tests fairly soon.